This
you'll help.
conference will now be recorded.
You'll
Yes.
also help me to watch out the chat messages. If there is any issue posted, then maybe you can alert me
Yeah,
in
sure,
terms of
sure,
audio.
sure. Yeah.
Okay.
If in case audio or any other things, then I'll immediately let you know, sir.
Okay.
And then, sir, just one small announcement. I'll just make it because some people are sending a mail. So just give me some 10 to 15 seconds, sir.
Sure. Sure.
Yeah, participants, we are getting a request saying that they are not able to change the name because this name and email ID is mandatory for the attendance purpose because the attendance is auto recorded. So I'm just helping out in the desktop. So once you connected via this app, started meeting via app, you can find the icon left side top. There, go to meeting will be there with the small arrow key. You just press it. There you will get a preference. On the preference, you can see startup, general, meeting, recording, integrations, audio connections, audio, webcam, and all. So there in the general, you can rename your credentials. Say like your name and email, you can enter in that part. So first you have to connect via the app, means the Windows app. Then you have to go to the top left, and then there an arrow key will be there. That logo called Go to Meet. There a triangle icon button will be there. Once you click there, you will get a preference. On the preference, change your credentials on the general category. Thank you so much. Thank you, Vignesh sir. You please start the session.
Okay. Good morning, everyone, and I welcome you all to this fourth day of this session. So today, a couple of sessions I'll be handling. So essentially, it will be on uh, pragmatic data analytics. So how practically data analytics is happening in the in the external, I mean, in our world. Hope you would have spent some quality time in knowing about what is data analytics and why it is needed, and how do we build models, how ML is helping, and what do we do using deep learning and the recent technologies. Okay, but let me try to give you a different perspective. I would say a more practical oriented perspective. So first, let us now start with few quotes. I don't think that these are all new to you, so you would have come across like this. Many more quotes you would have come across. But one of the common thing is data is a raw material, right? So that is what every quote reflects. So data is raw material. One, that is the thing that I'd like to go with. And data is oil, so that is compared to oil. So as how oil has, helped to grow, the Middle East economy. So the data is the new oil or oil of this century. And so the data increases in value the more when it is connected. So we have data, so no one is going to deny it. So everyone is having data, but how are we using it? So the more they stay isolated, less is the value. So the more you connect it, the more will be the value. So that is what is the sole purpose of doing data analytics. So we have enormous amount of data around us, but how are we making use of it? How do we do it formally? Okay. Um, so everyone is aware that even now, so many startups in terms of data analytics, data processing, or any company that is around this data, so there is going to be, we call it as a startup bubble. So there are so many companies getting, coming into existence. So whose main functions is around this data business. So we have seen some quotes, but let us start with some questions. Okay, so since this is a kind of a remote or a webinar kind of stuff, so I cannot expect an interactive session. So maybe I'll post the question. Maybe I'll give a couple of seconds. I'll pause for a couple of seconds. Maybe you can try to check. So what answers do you get? I won't say that whatever I have put in the slide is the correct answer, but Maybe you can try from your end. So basically, what do we do with the data? So be it any data. So what do we generally do the data? So basically, we collect the data. We do something called as, I would say, just more empirical or more high level terms of process. What process do we do? What level of or how deeper it is going to be? So that is up to us, up to the context, or up to the problem that we are trying to solve. But in general, when we collect the data, we store it, we process it. At the end, we are trying to get something out of the data. So that processing should help us to make some decision. Am I right? So simply, no one is collecting data. You take any scenario in our real world. So not in the perspective of computation, not in the perspective of a bigger application, big data application or ML application. So take a simple application, or take anything that we do around data in our day-to-day life. So we just collect the data, we process it. At the end, we try to seek, can that data help me to make some decision? Okay, essentially, so we can combine the whole process as simple as that. I hope most of you would agree with me. Let me give you some scenarios. So this is what I know as the people who are in the academic world. So most of the time, when we face some examinations, I hope everyone would have crossed that stage. So when we are preparing for some examinations, we take set of the older question papers. We just approach the question bank and we just do some analysis of what topic, what is the likelihood of that topic has got a repeater, what is the kind of repetition in the past, what is the likelihood of this particular topic or this particular question to appear in the current semester or in the exam. So basically, how do you just collate all last few years question papers. You just go question by question and you just count the frequency. Okay, and you're trying to basically arrive at some relationship between question paper to question paper, topic to topic. Okay, so this is what basically you do, right? Okay, and every year, I mean, so in our country we have this JEE or GATE examination. So every year, one IIT takes the responsibility of conducting the GATE examination. So if say for example, IIT Bombay is going to conduct, has conducted in the past so many GATE examinations, what is a kind of topic when it comes to computer science? So they focus more on. So basically, we have data, maybe the older, I would say here the data is the previous historical data. In it, is there any relationship among the data set? Is there any relationship from question bank to question bank? If a question is prepared by, say, IIT Bombay or say for a specific institute, what is a focus? What topic? What is a key topic they would be focusing more on? If a particular faculty is going to prepare a set of question paper, then what would be his focus on it? So this kind of analysis basically we do so without applying our thought, or without meticulously doing or applying any data mining or any sophisticated algorithms. So out of the box, we do that, even though we do not know how to name it, but we do that often. I hope that everyone would acknowledge me that so this would have helped you in the past. Okay. And recently, the second case was fascinating news to many of us. So last year we launched on part of this Chandrayaan mission 2. So we launched a Vikram lander, but just before it could land on the surface, it went missing. And a huge search operation was initiated by both ISRO and even other space agencies have pitched in to help us. And what happened, every now and then NASA has got some rover over there, which is still, I believe, is rotating around the moon. So that captures that specific location where it would have crashed. So that picture was sent by NASA every now and then. You would have come across this news, one particular engineer from a techie from Chennai, he has collected that visuals and he was able to finally crack down at the position, the probable position it would have crashed. So everyone was surprised, and even NASA has witnessed it, and NASA has published it on their Twitter page that some techie from India has helped or located the probable location of the place where Vikram lander would have crashed. So this was a fascinating news back then in the last year, maybe around in the month of November or October. I'm not sure about the exact month and date. But when he was giving interview about how he has done it, so it is basically image, analytics. So he did not apply any mathematics or any computers, sorry, not computers, but any algorithms or any machine learning models. But he collected all the images. Each image would be of, say, somewhere around 1.7 GB, somewhere around 2 GB of data, and which has got large number of pixels in it. Okay, so it took a lot of effort for him to visually, manually, to check place by place. Okay, and he has got compared it with day 1, day 2, day 3, day 4. Is there any visual difference between day n and day n-1, n-2, n-3, and so on? Finally, he was able to crack it, and this could be the probable place. And he has sent his findings to NASA, and NASA has acknowledged it. I hope everyone would have come across this. What I'm trying to say in this is, he has collected the data, but it has put here the processing is nothing but compare image by image, location by location, chronologically collate them. So day 1, day 2, day 3, and check, is there any similarity or is there any difference? Okay. So finally it helped him to conclude this could be the probable place where it would have crashed. So again, I'm repeating, he did not apply any image classification algorithm or some sort of that. So visual or manual effort with which he was able to crack it. Other thing is like customer profiling. Everyone, I think everyone of us is having some bank account with some banks, and you maintain your personal account or salary account, and often you would have noticed that whenever there is going to be some suspicious transaction, you would get alerted. What do I mean by suspicious transaction? Say, for example, you live in a city. Let's take that you live in Mumbai, and your withdrawal style is like on day 30th or day first, you get your salary credited, and the bank would have profiled your transaction. Say, for example, on 5th, he is going to take, say, 10,000. On 10th, say again, or again 10,000. Okay, and in between first and 10, so he will be having some EMI deducted, so that is automatically that gets deducted. So let's say to 20,000. Okay, at the end of the month, towards the month end, he may take some 5,000 to 15,000. Let's say that this is how the customer have profile, and most of the time your transactions are based out of Mumbai. Okay, based on your historical data. Okay, so the bank records this day in, day out operations of your transactions for every customer. They cater their services. They basically profile it. This is what we call as profiling. Okay, another example, I would say that Google. So when you use Gmail, let's say you're based out of Delhi, and you're logging in, you're checking mail every day from based out of Delhi. For some reason, to attend some conference, you've gone from Delhi to say US, and you're logging in from some cities in the US. Immediately you would get some notification, or some alert saying that a suspicious activity is found based on your account. So based on our historical data, your usual IP address is based out of, say, Delhi or nearby cities of Delhi or maybe India. But suddenly we could see that some logging in activity is detected from the non-Indian IP addresses. I hope some of you would have experienced this, and they would say that this looks like a suspicious activity. Is this the one? Is this you who has done this, or is it something else? So if you suspect that you haven't done it, then you can change. You will be advised to change your password. Okay, here the decision is detecting the unusual activities, and they will be alerting you to change your password so that your account is not compromised, your account is not hacked, you don't lose your data. So coming back to our customer profiling, so I said like a customer is going to be profiled maybe a monthly, so the interval is going to be monthly, maybe weekly, maybe in a specific day. Usually you go to ATMs between 10 a.m. to say 6 p.m. all of a sudden in one fine, somewhere around midnight, some transaction is going to happen, which is termed to be an anomaly or some suspicious activity. So the bank would alert you, or all of a sudden. So based on your 3 months of profile, you have never withdrawn more than say 15,000. All of a sudden, for some reason, there is going to be a transaction worth of say 50, say 60,000. I hope that you would have faced this. Immediately you would get a call from the bank saying that it is you who has done this transaction. So we have sensed that there is going to be some huge amount of transaction, so which we have never experienced, which we could not find in our system or profiling. Okay, so this is what is called customer profiling, and this is an additional service the bank is offering to the bank. So what is the benefit of it? Okay, so nowadays we find so many online scams, so many fraudulence, happening on banking domain. So every now and then we keep getting complaints. But how to prevent it based on your data? So one way to do this is to profile your customer. So you record their transaction day in day out. Get a statistical inferences daily basis, weekly basis, monthly basis. Okay, so this helps to in either way it benefits. In some way it helps a bank. On the other hand, it helps the customer. And the last use case, there are so many use cases, but to set the context, I have taken few from simple to moderate level of complexity. I hope that you must be aware of many other use cases you would have come across. Another use case is churn prediction. So what do I mean by churn prediction? If I am the service provider, so I would hardly like to lose my customer. Okay, so nobody wants to lose their customer because they are their bread and butter. So the more is the customer base, so that is going to help them in many ways. It is going to help them in have the higher share value or better position in the segment or market. So how to how to do some prediction so that and then the company is going to predict, or how to have some analytics in place so that it is going to predict a customer is likely, a potential customer is likely to get away or move away from the service provider, might go to a competitor. Is there a way to do that? If it can be done, okay, the company would make some efforts to stop the customer from moving away from him. Okay, so that is what is basically called a churn prediction. So most of you even would have experienced this. Like you may be a subscriber, or you may be a service consumer from a specific broadband or maybe a specific cellular company. Due to some reason, you're not finding that service is okay, or the support is not good. Okay, in the past you used to make so many calls, or you used to burn so many gigabits of bandwidth, but nowadays this has come down. Okay, so the company would the service provider would go through all this metrics and would be checking at this data, and maybe so they'll try to check. So one of the customer care executives would be in touch with you. So we could see a drop in your usage pattern. So is there any problem that we could sort out? Okay, so these are the corrective measures. Once a customer left that service provider or left the company, then it takes a lot of effort bring them back to the fold. But instead, if it can be predicted well in advance, okay, so it is going to help them. So they're going to retain their customer. And another example, before I move on to the next slide, I would say that so how to detect the delayed payments. So I hope that everyone would be attached to some EMIs, loans, or banks. Okay, so what if there is a scenario that is going to promptly alert me, okay, this is the due date, so can you please make the payment? So just before a couple of days before the due date, we might get calls, we might get some SMS, might get some calls. In a couple of ways, it is going to benefit either of the parties. I, as a customer, so I will not be missing out the due date, and my CIBIL score remains higher. Whereas on the service provider part, so he's able to collect all the dues on time. so that his financial position stands good. So these are the few examples. Basically, different segments of people, use the data. Even nowadays, in the past, you would have witnessed how even political parties are using data to project or predict or forecast their stand in the coming election. So you would have come across the news of Cambridge Analytica and how it has happened across the world. So basically, now you're able to correlate from the previous slide. So data is the new oil. The more you refine it, the more you are able to connect it. So you're getting more value. So it is, the data is not limited. Okay. Hope I'm audible now. I went unmuted. Yeah. Okay.
Yes, there is some disturbance in the participant side, sir. So we used to mute all once.
Okay. Okay. I thought like when I talk about something about politics, I was muted.
No. Sorry. No, like I can hear some disturbance at the back end.
Just on the lighter note. Okay.
Participants,
Okay.
please mute your mic or don't unmute your mic. Thank you.
Okay. Fine. And in the recent days, we are coming across this new term called data ops. I hope you would have heard about something called as DevOps. I believe yesterday on when the session was about Docker, the presenter was talking about what is DevOps, development operations. And in the recent past, in the last couple of months, in the industry, we come across this term more frequently, data operations. So what it is all about, and why it is getting momentum. So before I answer that question, so let us go back to one more question. So why should we bother about the data? So from the previous slide discussion, that that when we properly approach the data, so that is going to help you. See how it helps you. So it helps you in make decision. That could be a corrective decision, or that could be a preventive decision, whatever it is. In some sort, in generic way, I said that. So it helps you in making decisions. Okay. So why should we then bother about the data? Anyway, it helps you, but why should we, or how do we deal with the data? So you have historical data, you process it. At the end of the process, or you process the data such a way that it helps you to find out, is there any relationship between the data? Okay. So that relation can, in the more formal way, we can say that a model. Okay. So to understand the discussion, I said that relation. So I got data 1, data 2, data 3, data 4, and data n. Okay. Among this data set, is there any relationship? So what is that relationship? If some factor is changing in data 1, what is the likelihood of other data sets getting changed or aligned? Okay. Take for example, so government is going to announce budget today. Let's assume that. Okay. So the government is going to give stimulus package for infrastructure based projects. You would have observed this, right? So all infrastructure projects, so the government key focuses on the next 3 years is to give stimulus so that the infra across the country is going to be supported. So this is the announcement that the government is making in the budget session. Soon after that announcement is made, maybe on the same day or maybe the next day, all the infrastructure related companies, maybe some construction companies, or maybe the manufacturing companies which helps construction, maybe cement manufacturer, maybe the steel manufacturer, maybe the key player in some construction related projects, you could see that their share value is going high. So one announcement is shaking few segment. Okay. So likewise, when there is going to be any other announcement, you could see that adversely if it affects some other charts. So this is what I say about relationship between two different events or two different data. Okay. So the key focus is how do we process the data, or how should we have the processing mechanism in place so that it helps us to identify the relation, the model. Okay, so why do we do that? So how it is going to help us? Once if I get some model or that relations, how it is going to help us? So here in this process, we take historical data. From historical data, we want to try to find out, is there any model or relationship among the data set? Okay, so whatever process we are going to apply, so that is the intention of the process. Take you just try to correlate this with the previous examples. Take take for an example this customer profiling. So they take all your previous data and they try to find out any pattern or not. With this, when they give you the new data, it is going to predict. Okay, so when you build the model using the historical data and take the newer data, and it is going to predict whether this is a suspicious activity. Like I'm the customer of a bank, I got my account in the month of May, so the bank would profile me for next 3 months. On 4th month onwards, whenever there is going to be any anomalous transaction or any suspicious transaction, then it is going to alert me, or it helps the bank or me to take the respective corrective action. So let me pause here before I answer the question of data ops. So let me switch back to some Excel sheet. I believe I have some Excel sheet. I hope my screen is visible. So let's assume let's take a look at this Excel sheet. So this simple Excel sheet, which contains data about the T-shirt size. Okay, so this is pretty standard, right? So if you visit any shopping portal, or if you just get into any clothing shop, there you could find this information. If you're going to directly visit the shop, then you can get the appropriate size. But if you're going to order it online, so they'll just give you this guideline. If your height in so and so, weight in so and so, and this is the T-shirt size. So to make our understanding clear, or to make this discussion simple, let's focus on these two data items: height and weight, then the T-shirt size. For time being, just forget about this Euclidean distance. Okay. Here, our interest is to find out, is there any kind of model or relationship between this data points, height, weight, and T-shirt size? Okay, so if it could be found, so this is very limited data set, right? It has got only 140 centimeter to 170. Okay, and it is not continuous. This is discrete. I mean, the doesn't have any continuous value from 140 up to 170. So from the crowd, we have just taken some sample, and if I'm going to give any new value, whether I'll be able to predict it or not is what is my exercise. Okay, so what I can do is I can try to find out the regression between these two data points. So let me do that, a simple exercise before we move on to the presentation part. Let me select X and Y range. Let me select. So I'll let you know how to do this using Excel sheet at the end of the session. So I hope that this plot is this chart is visible. So we have got the weights on x-axis and height on y-axis, and using this we have just drawn some regression line. So using this regression line, we are going to predict it. So what I was saying something about the model. So what is the model found in this chart? Let me go to this. layout and yeah. Okay, so with the help of this, let me explain about this model. And so everyone would be familiar with linear regression problems where or the equation for the line. So whenever you come across the concept of data analytics, the simplest data model, the data analytics mechanism is linear regression, simple linear regression. So where you would be finding out the tangent of a line using the very simple mathematical equation y equals mx plus c. Okay, so here I have some equation y equals to 0.8x plus 110. Hope everyone is able to see this information. So this is the equation of this line which passes through all data points. Okay, so I have this equation. This is what I say, that a relationship and model in a mathematical way. So why should we bother about why should we try to have this relationship in terms of equation, in terms of a mathematical model? So I'll address that a little later. But having this data points like height and weight and t-shirt size, so my objective is to find out if I just give some unknown value. I've got some historical value, but if I just say I don't have any value for 155 here in this Excel sheet, but if I just give 155 as my height and say 60 as my weight, okay, so that pair is not in this document. Okay, 155 and 60. If I'm going to give that pair as input, how good this model will be able to predict? Okay, so that is the objective of this problem. I got some historical data. So this is what I'm doing. So this has given me some equation y equals mx plus c. So here m value is 0.8, c value is 110. So using this for the unknown value, if I'm going to give, whether I'll be able to predict it or not. So that is the objective. So now I hope you might have understood what do I talk about relationship. So using the historical data, you build the model, and using that model or the mathematical equation, you try to solve it for the newer data. Okay, so why do we bother about the historical data and try to find out some mathematical model? Since we deal with large amount of data, so you can't solve it using manual efforts, of course. And most of the data you can codify so that the computer can easily understand it. Okay, so that is the purpose we are interested in mathematical models. So once we are able to derive mathematical model, once we are able to turn your data into something which the computers can understand, doesn't matter how much ever data we have at our hand, easily can be processed. So still this question is unanswered. What is data ops? So to answer that question, let me take a clue henge from this diagram. So this is a typical diagram. I would say that pragmatic oil refining. So we all are aware of how we are getting oil. So when we need some fuel, then we just go to petrol pump and we get it filled. But where it all has come from? Okay, where is the source of the oil and how it gets refined, and before it reaches us, what are the intermediate stages it goes through? Okay, I try to correlate this with data processing and analytics and the byproducts of data analytics. Fine. So we have crude oil, coming in from we may mine it under the sea, or we may get it exported. Okay, so it reaches pumping station and we construct a large pipeline. Okay, if you just look for a oil refinery pipeline, you would see huge lines of pipelines being laid over for a longer distance before it reaches the refinery. So from the source to the refinery, you would construct a larger pipeline so that the raw material is passed to the refinery. Then at the refinery, you apply all your processing. Okay, so there are some standard procedure using some different chemicals. You just refine your data, you process your raw material, not data, you process your raw material, then you get some byproducts. So the first quality would be useful for the aviation industry, say aviation fuel. Then comes other general purpose vehicles. Okay, so this is the process, or this is the overall view how that describes raw material to usable fuel. I'm trying to take some design cues from this diagram to explain what is data ops. Okay, so our focus is only on this area, data analytics. So for past few days, our focus is only on this, right? So data analytics, how do we do that? How do we construct, how do we make use of mathematics? How do we make use of probability concept? How do we make use of ML models or deep learning models to do this? But we are at this layer. But have you ever bothered about what about the source data and how it reaches here? And moreover, for the amount of data that we deal, whether do we need this mechanism to be in place? What if I'm going to get larger amount of data? So that is the focus of this discussion. That is why I've named this but a couple of sessions as pragmatic data analytics, how in real world it takes place. So again, this will be this got connections from the previous session. So like in the past 3 days, you would have seen some information on mathematics, some information on machine learning models. Okay, so all that concepts, whatever we have studied, gets applied at this layer, data analytics layer. So we'll be building models, we'll be making use of scientists, data scientists, and data analysts. But before we reach here, we need something called as data engineering. So the data engineering is a process where we would be focusing on building data pipelines. Okay, so I have a session on data pipelining, so where I will be taking you through certain tools. So the objective of that session is to how to get raw data. The raw data could be your text file, the raw data could be your social medium, the raw data could be their database, the raw data could be your audio, video, or whatever it is. Okay, so before you do start analytics, how will you build this pipeline so that from here it reaches your data engineering? So this is where at this data engineering, so what do we basically do at data engineering? We build our data storage, we build our data warehouse, data lakes, and computing infrastructure. Okay, I hope in the last yesterday you had a session on Docker, and the presenter was taking you through AWS, how to create your own infrastructure using AWS, or say for example, if you go back to your college or your institute, how to set up a distributed environment that helps you to store your data. Okay, I mean basically you would, before you jump into do analytics, you should have a proper, foolproof, highly resilient data and the computing infrastructure. So without proper compute and data lakes in place, you cannot process your data. So data engineering is a previous stage, the stage prior to your data analytics, which we should be considering. Before we get into data engineering, how are we going to ingest all our data? Okay, so this is what I talked about, data pipeline tools. So basically what happens here, it focuses on data capture related processes. Whether it can be a batch process, or you may write a couple of SQL queries to get data from traditional RDBMS. So RDBMS have been in existence at least for 3-4 decades. So many voluminous of data are still existing in SQL databases. How to get data from the legacy database so that it reaches the data lake? From data lake, you can build model, or you can get simple log files. Okay, there are a couple of use cases wherein network related security, so the user logs should be captured. So how to get user logs so that it reaches your computing infrastructure from when you will build models. Or nowadays we are interested more on streaming data. So it is not going to be batch. As the data comes in the wire, as the data comes in the network, you have to capture it. One of the application would be like cyber security. Cyber security, as the incident takes place, you should be able to look at the network details, maybe packet or network related information, and you should be able to process it and try to be able to find is there any security breach or cyber attacks is going to take place or not. Okay, so again, so we got multiple sources. So if we just compare it with the previous refinery analogy, so the oil comes from different places. It might come, the crude oil might come from sheep, or the crude oil gets it comes from the sea or under the riverbed, you can get it like that. You have data from the existing systems data, social media, and there are no bounds to it. Even nowadays, social media plays a vital role to give you data. So Cambridge, in case of Cambridge Analytica case, so they've got all the data from social media. So this what is the discipline of data pipeline. So before we have data analytics in place, we should have focused on this. So do we have enough data infrastructure, maybe the compute infrastructure in place? Do we have the right data lake, data model, data warehouse concept in place? And do we have the proper data ingestion or data pipeline in place? So basically, who will be involved in each of the stages in case of data ingestion? So we call them data architects or DBAs, database administrators. So basically, they will be able to get you this done. And when it comes to data engineering, so we basically call them data engineers. So the overall picture that I put here is the answer of data apps. How are you going to make use of data? How to build a data pipeline before you get some meaningful information out of it. So once we have everything in this place, what are we going to get is like your so once you prepare this data in this way, so these will be the consumers of your data, maybe data scientists, data analysts. Maybe you can build some dashboard visualization out of it. You can sell this to a customer. This helps you to make some decision. So we have seen a couple of examples like churn prediction or customer profiling. So once we have set all this in place, then the reports, dashboards might help us to predict any suspicious activity. So this is what is data pipeline layer. And so whatever we see under this data process, so this is what is called as DevOps. So the whole of this is put together as data apps. So this is DevOps. So you would have come across this term, whenever you just go through IT related and use. So DevOps. So DevOps is continuous development and continuous integration. So continuously you will be developing features and continuously that gets integrated so that the end user is able to see the relation. And these are the underneath technologies. So what helps you to achieve this? So when it comes to data integration, so you should have ETL, MDM, master database management and profiling, validation in place, and data preparation, data catalogs and data collaboration that you should have in place. And when it comes to data analytics, you should have data science tools, dashboards, and BI tools. So collectively, all this tools, techniques, process put in place is called data apps pipeline. So why have spent so much time on this? Before we get something solid on data analytics, we are familiar with machine learning models, we are familiar with data, we are familiar with use case. Okay, we are familiar with statistics or mathematical model, but how to put everything together, whether we have enough combination of people in place, enough roles in place to achieve data analytics, or how to basically approach that problem. So this is a simple guideline. Okay, whether do I need all this for my use case, that is up to you, that is up to the complexity of the use case. But say for example, the amount of data you're going to deal with, the amount of data that you're going to deal with, the problem of your interest is not that great, then you can merge these two layers together, data ingestion and data engineering together. Okay, so you don't have to have a complex compute infrastructure. Maybe you can make use of at least some 5 to 10 servers in your academic institute, and you can build some NoSQL database, NoSQL based data lake, and on top of it you can run your data analytics model. But what if there is going to be a complex use case? Okay, and say for example, so everyone, I believe we have Aadhaar, right? In India, every citizen of India is supposed to have Aadhaar. Have you ever thought about what is the volume of the Aadhaar database information? So where it is managed, how the data is preserved, Okay, so in a country like India, we are of 100 crore plus people, all people information, and we basically store your demography information, your biometric information, your personal information as well. Every information is stored there. Okay, so when it comes to personal information, they're going to be textual information, but when it comes to biometric information, so they capture your iris and they capture your thumb information, and for all the citizens, think of the volume magnitude of the data, 100 crore. Okay, so in that case, so this will be a huge effort is needed to set up this data store. So that is why I said, like, based on the complexity, based on the use case, either you can have independent layers or you can merge it, but this gives you an overall idea. So before you have something solid in place, you should have thought about this. So let us start with a few let us spend some time on understanding about what is EDA, exploratory data analytics. This is the first step we are supposed to do. Say, for example, you've been given some data, so what you are supposed to do as a first step? First is, like, you should do exploratory data analytics. We just go back to this screen. I said, like, when you get the historical data, you have to process it so that it helps you to understand the data. First, you should understand what is there in the data. Is my data correct? Okay, I hope you would have had some session on data pre-processing. So why should we do pre-processing? So that you have understood the data and you have found some anomalous entries in the data. So first you have to be cleaning it off. Okay, so what process should I do so that it helps me to identify or understand my data? Is my data clean? Does it contain every information? Is the data whole? Okay, is something to be missing in the data? Should I consider it or should I remove it? Okay, so what process helps you to understand your data? So that is something called as exploratory data analytics. So how to basically do that? Okay, and what is descriptive analytics? So these are the few topics that we would be discussing in a couple of for the rest of the session. So I'll take some 20 minutes more to cover the remaining of the slides. I'll reserve last 10 minutes for any Q&A or any things to be answered. So before we proceed further, so I'd like to talk about this, like the data world, how it looks like then and now. Just compare the present scenario with a scenario that we had in some 20 years back. So in the year of 2000 versus 2020. So back then, the volume of data is very less and manageable. So when we say back then in 2000, data is going to be only simple text files or maybe a database, maybe log files. That was as simple as that. But today, whatever you see is data. It could be no longer we are restricted or we are limited only to textual data. It can be an image, it can be an audio. If you just take any medical records, you would have come across use cases wherein we deploy machine learning models. So by just looking at the images, by just looking at the scan reports, the ML models are able to predict what kind of disease could be there behind this X-ray or scan report. So that is a kind of data that we have. So we are no longer limited to a particular data type. And they would have come across a use case wherein you talk in one language, the ML model or the data analytics system is able to understand it and translate. Auto translators are able to translate. And even you would have come across certain applications, even mobile-based applications. If you take a snap of a picture, you take a snap of some description in some language, so it takes the pic, it gets that, and it recognize the character in it, and it just translate it into another language. So these are the few types of data. So the data is not limited. So whatever you see is the data. And the type, back then it was mostly structured, but today it can be anything. It can be anything. It can be unstructured, or it can be semi-structured, or it can be structured as well. And back then, most of the data was data at rest. Like, you just collect the data, then you process it. It is going to be it was batch processing. But now, as the data comes, you have to process it. That is what data streaming or data at motion. As well, you have to even process the historical data. So back then, the storage requirement was very minimal. So using a couple of machines, you were able to manage the data. But now it has becomes enormous. So there is no limit available physically. There is no limit for the amount of data to be preserved as of now. Just an example, to store 1 billion citizens data using Aadhaar database, so you can think of the magnitude of the data. So it is not just data storage, as well as operations on the data. So you just stored all 1 billion citizens data, but the moment when it comes to search for a particular information, by just giving in an Aadhaar number, you want to get the government agency wants to know information about that citizen. Even the data manipulation has to be as fast as they need it. And back then we were having few devices. So because nowadays devices are contributing to data, but today everything is a device. Everything has got some IP address. So we ran out of IPv4 address space, and we had to invent something called as IPv6. And because of this IoT, Internet of Things, whatever you see could be a device. It could be not just the computing devices. So as far our understanding so far, we've been thinking like a mobile device or maybe a laptop, a desktop, a server is the one who has got IP address or who can be part of the network. But gone are the days. Today, a car can be a device which has got address, a door, a chair, or whatever you see can take part in the network. So just think of the explosion in terms of network. And use cases are complex nowadays. But besides all this realities, what are the opportunities do we have? So we've got so many advanced algorithms, data structures, and NoSQL and bitmap database. So based on the context, we can pick any one of this and we can solve the problem. And the network speed, so that is very promising. You've got interconnect pipes up to one TB speed. You've got two different data centers. To connect them, you would need high speed of bandwidth. You need higher bandwidth and in terms of data pipe. And we have so many advanced technologies in terms of data storage. One promising thing is SSD. SSD is versus SSD versus disk-based storage. So disk-based storage normally is going to be 5,000 RPM or 7,500 RPM or 1,500 RPM. So versus SSD. SSD is much faster. So when you are about to retrieve some data, so SSD is going to be a promising one. And on the other hand, so we see a lot of applications coming up with GPU, the graphical processing unit, so which will be having hundreds of cores. The server, the powerful server from Intel nowadays might have somewhere around 72 logical CPU. So 24 physical CPU, then hyper-threaded. So maybe it would come around 72 or 80 or 96 CPUs. For that, you would have to spend somewhere around 1 million to 1.5 million. But whereas in case of GPU, for that amount, you will be having thousands of cores. So that is the advancements, and FPGA and SmartNIC based on the type of application. So what I'm trying to say is these are the volume of data. So these are the threat, I would say that, but these are the opportunities. So by just rightly blending them, still we can crunch the data, we can process the data. Okay, so let us start with how do we basically do exploratory data analytics. So basically, when we are about to analyze the data, so based on the problem, either we may consider the entire data set, or we may take sample from the population. So first step is to take sample from the data. Then we do exploratory data analytics. So why do we do that? Okay, so we have to analyze all our data, but why should we do that? So we're trying to basically listen the data. So we are trying to solve a problem, but let us hear it from the data. Okay, so before you solve a problem, there is a saying, right? So if you understand the problem, then you are at 80% of solution. So unless we understand the problem, what it is, this applies everywhere. This is getting applied everywhere. Okay, not just mathematics, but be it any problem, name it any problem, the more you understand the problem, okay, so the more you have the solution with you. So that is what we are trying to do in ADA. So we are trying to understand the problem. So to check whether every data is correct, is there any mistake, is there any pattern, is there any kind of deviation in the data, is there any anomaly, is there any null value, how to fix it, what is the mathematical model available. So that is what is basically ADA is going to help us. So to do that, so the first step would be, the next step would be categorize your data. Okay, so how you can classify your data. So it can by just looking at the type of the data, you can basically classify whether is it binary data, or is it a nominal data, or is there any order in it, or is it discrete, or is it a continuous data. So basically by just looking at the data, you will be trying to group them. Then you have to decide the dimensionality of your data set, whether your data set contains one variable, or has it got two variables, or it has got multiple variables. Okay, so take for example bivariate data. So take for example the t-shirt data set which I have shown, so which has got height, weight, and t-shirt size. Okay, so but we have done our projection using two variables. Okay, the weight and height. Multivariate, take for example in case of customer profiling, where I would be considering multiple variables. Take for example loan sanctioning. It's a common case, right? So somebody is going to apply for a loan. So the factor is first they will consider his age, his employability, whether he's employed or not, he's doing business or he's salaried, how much he is getting, and what is his CIBIL score. If he's got a good CIBIL score, then you'll have higher chances of getting. If the CIBIL score is bad, and outrightly the person will be denied with loan. So here that use case might need many variables. So based on the complexity, based on the use case, then we have to take either of the approach. Then to understand it better, then we have to do this numerical summary of data. So there are some standard approaches: central tendency measure, variation or variability measure, relative standing. So in the first case, central tendency, what are the data items that could be found around the center? So what is that center? Then we'll see in the next slide how to define the center. What are the mathematical terms that helps us to define the center, and how the data is spread either directions of the center. Okay, so that we will try to get the data, we'll try to fix the center, and how far is it spread with respect to the center on the left direction, the right direction. Okay, so basically why do we do that? So this helps us to find the lowest in the data set and highest in the data set and anomaly in the data set. Okay, so take for example, you have just taken some data set to predict age versus some disease. Okay, so let's say that we have collected data from age number 5 to say age 150. Does it sound good? Okay, so age 5 and 150. Maybe there may be some wrong in my data set, or maybe a person would still be living up to 150, age 150. But for the use case like age versus disease, okay, the doctor would feel that, okay, I don't need this spread of data, but what I need is like from age 20 to 60, that is enough. Okay, then below 20, we would say that the minimum would be set as at 20, the center would be say around say 40, and the maximum would be 60 or 65 or 70. The rest we would say that anomaly. See, obviously 150 is anomaly in our case, right? So we don't see much people living up to 150 years in this day. So it can be eliminated, or that can be excluded as an anomaly. So you have to make all those decisions. So how you will be able to make all this decision? What helps you to make the decision is what all about numerical summary of data. So you just look at the data, so try to find the center, try to fix minimum maximum, try to plot it. Next we'll be looking at how to plot the data. Okay, so by just doing all this process, you'll be able to find minimum, maximum, and what data range should I consider, what should be included, excluded. And the relative standing. So with respect to a data point, what is the preferential or relative position, the newer data set that I feed in? So there are a couple of mathematical terms that is going to help us I hope most of you would be familiar with this, but let me do a quick recall on each of this topic. So first one is median. How do we define median? So median is as simple as an average. Take all values divided by the number of occurrence. And there are other variations in terms of means. Like one is like weighted mean. You can consider the input value, but each input value should be given a specific weight. Take for example, in case of loan sanction, age versus your CIBIL score versus your employability. But you are at the good age, but you got some decent salary and you got a good lifestyle, but your CIBIL score is bad. Okay, so comparatively nowadays bank give more weightage on the CIBIL score, right? Okay, so not just input would help you always, but the input should also be associated with some weight, so that that particular data point in case of your loan sanction might be affected because of the weight assigned to your CIBIL score. CIBIL score in use cases like this would be given higher value. Next is median. Median is exactly the center value. So how do we do that? So basically when you're given a data set, you just try to arrange them in an ascending order, then try to find out the middle value. If it is going to be odd number of observations, then you can find the middle. If they're going to be even number of observations, you take to find middle two values and you just average it out. So this is going to help you median. How are we going to make use of this mean, median? The next thing is mode we'll also be discussing. So how are we going to make use of it? So we'll make use of certain diagrams to understand it. So I'll take you through that slide. So mean is best to describe symmetric distribution without outliers. So what is outlier in case of age versus disease? 150 is outlier, right? So median is useful for skewed distribution. So the next term that is going to help us is variance, average of squared deviations from the mean. Why do we square the deviations? So when we get some result in negatives, and so we don't want to eliminate. I mean, we want to eliminate all negatives. So that is why we square and square the deviation so that the negative is going off. So we are interested in the magnitude. We are not really bothering about the value, but we are interested in the magnitude. So that is why we always do squaring it, so that it eliminates the negatives. Here is another important factor which we would be dealing with: standard deviations. How standard the observations are deviated from the median, the central one. So variance cannot be related because it is arbitrary. So we want to have another approach, which is nothing but standard deviation. So how do we calculate standard deviation? So we take variance and we are just I hope this is the formula for variance, right? So we are going to take square root of variance. So square root of variance is going to be standard deviation. So standard deviation gives us a better understanding. Yeah, so this is what I talked about. So when you try to find your data and push, plot them using a plot like this, or better, I would say that a quartile like this. So what is a median? So the Q2 is going to be the median. On what percentage I have in my data set before the median, on what percentage do I have after the median? Try to compare this with our age versus disease. Okay, so I said like it would have started from 5 and it would have gone up to 150. Okay, but I'm interested only in this range. Okay, here the median is say 40. See, the maximum could be say 70 or 65. Let me say 70. Okay, so to understand my data better, I should have take some mathematical steps. First, we would have started with mean, median, and standard deviation. So and then we are trying to portray them using this box plot. So in the first quartile, we would be having 25%, and the rest is like 75% is larger, and we are interested in finding out the median. And while doing this exercise, we'll be eliminating all this anomalous data. Now, I would have started with data range, which is containing, say, 5 to 150. But once I apply EDA, once I apply all this mathematical reduction methods, at the end, I have only reduced data amount of set, then that helps me to focus more on my use case. So once this initial mathematical analysis done, then we would be trying to plot it. So far we have seen so many equations and mathematical procedures. And you may by this time you may be having some questions. So do I do all this mathematical stuff when I get some data? The answer is yes and no. Okay, still, if you want to understand the data better, you can take the data and you can load it in Excel sheet, and you can Excel sheet basically helps you to draft a mathematical equation, and you can find it. Or you can make use of some programming languages, and the programming languages got some set of libraries using which you can compute it. Okay, and nowadays, all programming languages support for this statistical libraries. Especially Python, I would introduce you to something called a scikit library, which has got standard libraries to calculate this mean, median, average, and built-in machine learning algorithm. So you don't have to write anything. This is what I would say, that you don't have to be I said like the answer is yes and no. So no means that you don't have to do all elaborate mathematical modeling. But in case of why did I say yes? But if you want to understand the data in different perspectives, say for example, these are standard formulas, but according to my use case, can I tweak the formula so that it better expresses the situation? In that case, you'll have to change it. So usually we'd be interested in plotting the data using box plot and histogram. So this is what is a box plot. So whatever I have explained so far in case of age versus disease example, the moment I put it in a box plot, so I'm going to easily consider, okay, only I have to consider the values from Q1 to Q3. So the minimum and maximum can be eliminated. So simply I would say that only focus on IQ or interquartile range data. So the remaining can be eliminated. Okay, so easily whosoever is looking at the data can easily understand it. And when you get multivariate data, so you have to basically reduce the dimension. Here is a multivariate data, 3-dimension, 100 data points. Either there are chances that you pick up the significant data like 1 dimension with 10 points, or you just go for 2-dimension, 100 points. So what is the complexity of having multiple dimension, multiple data points? First thing is like computation is a bit complex, and the model to process data is also is more complex. Okay, but without losing the information or context or the essence of the data, can I reduce the dimension? Okay, so one method is like PCA. So using this PCA approach, you can reduce n-dimension data into smaller number of dimensions. So once this is done, this 2-dimension or single dimension can very well be expressed using machine learning models. Another chart that we would be using is histogram. So here the point is, I hope that most of you would be aware of what is bar chart and histogram, but let me try to essentially highlight the difference between the bar chart and histogram. So bar chart essentially compares items in categories, but whereas histogram takes one particular category and try to highlight the distribution. So bar chart would take multiple categories, but histogram restricts itself to a specific category, and how in that specific category there are distributions. take for example, now I have to make some frequency chart. Then how to do that? So this is the data set which is given. That's how to do that. So basically, you can define the range. So 50 to 59, 60 to 69. If you can correlate this to age versus disease, so 20 to 29, 30 to 39, then you can summarize them. So once this is done, then you can create a histogram. So I have just constructed this frequency chart. So what I've done is, like, I would have started with data like this, but it doesn't convey any information at the first hand. But if we just apply this mathematical model or some charting techniques, and if you're just going to present it, it clearly conveys. I hope this you would have used in publishing your results. Okay, so how many of the students have scored 50 to 59, 60 to 69? Okay, so this gives a better picture than giving a big list of student information and putting them in an Excel sheet. And here are a few slides to talk about how do we basically draw box plot. And again, I'm repeating that you don't have to do it manually. If at all, if you're interested, then for the sake of understanding, you can get the data and you can basically sort it, and you can find out the minimum, maximum, median, first quartile ranges, different IQR, then anomalies. But I'll take you through Excel sheet where it can be how it can be done using Excel sheet. I will also show you a couple of Jupyter notebooks, Python, using Python, where you can see how certain tools and technology, tools are helping you to get this done. But why should we do that? That is the most important thing that we should be able to understand. So to understand my data, to portray my data, to explain my data to someone else. Okay, so I cannot be saying that look at these numbers, but instead instead of showing them the series of numbers to a series of data range, I can put some a couple of diagrams and I can show that. Now first you have to basically order it, then you have to find out the median. So here the median is 12. Then you have to find out lower and upper medians. So find out the median. So the median is going to divide your data segment into two. Then in segment 1 and segment 2, you find out the lower and higher. Then you have to draw number line. So the lower median is 8.5, and the upper median is 14, and the median is 12, using which we have drawn this. Now we have to draw a box around. Okay. So in this case, whichever is lesser than 3, whichever lesser than 5, and whichever is greater than 20 can be eliminated if we are interested. If our use case demands that, our analysis demands that, the rest only the data range from 9 to 14 is going to make more effective inference out of the data, the rest can be eliminated. But how to do that? What is a formal approach? So these are the formal approaches. Like we have to make use of mathematical notation and try to plot it using histogram or box plot. So I'll pause here, and we have 10 more minutes left. If we have any questions to be clarified, maybe I'll wait for it. Madhi, can you help me? Like, should I go through the? I could see so many messages on the chat box. Should I address one after the other, or how it was done earlier? Madhi, can you please let me know that? I don't find any response. Maybe Let me check. There are so many visitors. Everyone has wished good morning to all. I don't find much questions. Some I see some question. Most of the time, data features are of different type. How to process it? So I understand, since I do not have any opportunity to interact with the person to understand his question clearly. So this is what I received. Most of the time, data features are of different type. What I understand, if I'm not wrong, is the types are different. It could be a textual data, it could be structured, unstructured, and it could be or on audio or video, right? So take for example, if we are trying to do image classification, okay? So how to basically approach that image? In machine learning model, there is something called a CNN, convolution neural network. Okay, so one approach is like use case based models. You can straight away look at use case based models, so that helps you to build solutions around image based problem. So what are the image based problem? Like I mean, especially countries like India, we would need many data analytics, ML, deep learning based solution centered around images. So each state has got its own language. To understand anybody who is visiting our country, to translate the local message to the choice of their the language of their choice, we would need some system to be built. In that case, the input is you have to process all the images, or maybe to translate audio in one language to other language, or to transcript it. Somebody say, I deliver this lecture in English, transcript it to English and translate it to any other language. So here the data type is audio. Okay, so one straightforward answer is maybe look at the use case based algorithms. But again, I believe that I have not answered it fully, because I have to understand the problem more. So how to collect the data, how to curate the data. So there are so many other prior stages involved in it. So request you to refer back to the earlier slide where we talked about how to ingest the data, how to build a data like around it. Then the right model. With the help of that, we can.
So, Vignesh sir.
Yes.
Sir, I think there are some questions and comments on the chat box.
Yeah, I'm just looking at it. I'm just going through that. So one of the questions I've answered.
Okay,
and,
sir.
I'm just going through that.
Yeah, I just returned from Arul sir.
Yeah, I'm just looking at it.
Yes, sir.
So another question is on SD, standard deviation and importance in data set for application in machine learning. Okay. So what we have seen in this session is what is data.
Sir, 1 minute. There is some disturbance, I think. Just a minute. Yeah, I think I muted them. No idea whether they will come back again or not. Please proceed, sir.
Fine, thank you. First, when we get data, right, first thing is like we have to understand the data, right? So that is as equivalent or as important to understanding your problem itself. So how to understand the data? So to understand the problem, we have got some mathematical notations like mean, median. Okay, then we have to find some central tendency. So what is the central data and what is the tendency around the data? So this is what as a next step we have done. Okay, then we have to find out variance. Okay, so how each and every data is varying and how is it affecting. So what is the relative distance between the central data and the other data? So whether variance can help me or not. So variance to an extent it helps, but you might get negative values and the magnitude with the direction would be involved in it. To eliminate it, we go for standard deviation. So what is the uh, kind of relative distance between the central data and the data of our interest? So using this standard deviation mechanism, so that helps us to refine data in the given problem. We cannot be taking all the data whenever we are about to solve the problem because the data is sampled. We are not sure whether they reflect the ground reality. We are not sure. Okay, so consider an example: age versus disease. You got age of 5, you got age 150. Whether a person is still alive 150 years old, we do not know, or a person has mistakenly, the field officer would have recorded instead of 15, you would have recorded as 150. Okay, so we deal with numbers, then we are just taking chances. We're not sure whether they are real or not. Okay, because just because of one number 150 might change my central tendency. So earlier, if we do not consider 150, my median would be somewhere around 40 or 50. But the moment I include 150, so that is going to drift further. But that drift will still be making sense if we just can consider overall the thing. So if I'm going to consider 150, then that is going to affect median. Then so it affects variance and standard deviation, right? So to make a precise range of the data, so we make use of all this mathematical notation. And another question: do you think Excel is enough to do all such analysis? Certainly not. Certainly not. And I would say, then which version of Excel? Okay, on which computer? There are so many other questions to be asked on this in this line. Okay, see, I've got a computer with say 8 GB of RAM, then I can process only data up to 80% of what my computer would support. 8 GB of RAM, and say let's say 20 to 30% would be utilized by the operating system. So the remaining 70% is available. So in that case, 70% of 80 GB would be somewhere around 5 to 6 GB of data alone can be processed. Okay, but the moment you get more amount of data, no, it cannot be. But why I've taken Excel? Because Excel is still a rich tool to make us understand all this basic mathematical stuff. I've added one simple plugin to Excel, so then that helps me to do simple regression, histogram, and that helps me to understand the data. If I have some handful of data, so without learning any programming language, so you don't have to learn Python, you don't have to learn an R programming, you don't have to have any sophisticated tools. Okay, why we are fascinated about Excel? Excel is intuitive, self-intuitive. Like, so by just looking at the tool, you get some ideas. Okay, there are you can get the data from a CSV file. You can even enter your data. Otherwise, to feed data, take for example, there is no Excel, then you have to have some database. You have to you have to know how to write SQL queries, how to feed data, and you should be remembering how to use aggregate functions. But all these things are provided as a function plugins in Excel. Not only data manipulation functions, as well as data visualization capabilities bundled together. And to moreover, kind of a startup a lesson or the introductory lesson like this can we can make use of Excel. Some links where we can find some coding. Coding, I can share it maybe at the end of the session. Do some hands-on. Yes, the remaining session. So I'll take you through Google Colab. I hope that you would have installed the Python and Jupyter Notebook. But the reason why I haven't started the first is in hands-on, but let me set the context. Let me give you overview. Why Python? Why not other software? It is up to us. Wherever we feel convenience, then we can choose the software. Like because of ease of use, Python is gaining momentum. So especially in the last 5 years, and that too, machine learning, deep learning, people have started using it, and along with Python, R is also getting momentum. And but I would say that when it comes to complex application, complex GPU-based processing, the hardcore, intensive applications, and they use C, C++. They are much more faster. They're much more efficient. Okay. Again, it comes to the level of your comfort zone, if whatever you're feeling. And one more reason Python has got rich set of libraries. Okay. So you would have learned so many machine learning algorithms like simple linear regression, supervised learning, unsupervised learning, but without even write a bit of line of coding. Okay. So that library is going to support. The moment you say that you do simple linear regression, you just give the data, then that is going to do everything. That is going to predict. That is going to give prediction. Even an odd number, it told.
Yeah. Vignesh sir, this is Nagaraju here.
Yes, yes.
Hello.
Yes, sir.
Yeah, yes sir. As you are telling them that Python is installed in Jupyter Notebook. So in my sessions, which I have taken, I have given only the Python installation document, and some of them I might have already installed. But about Jupyter Notebook, I am not sure. So in case if you have anything to share, if you can share, I think before you come up for the next session, they will install it, I guess.
See, what I'll do is there are a couple of ways to get this done. So I thought like I'll go with Google Colab. Let me go back to my. So I'll stop my session exactly at. I'll take not more than 1 minute so that we'll break. So I hope few of you are maybe maximum of you familiar with Google, Colab from Google. So this is a hosted environment. This is being served from the cloud, Google Cloud, and only thing is like you should have a valid, Google account, Gmail account using which you can log in. I would request everyone I know to have some Gmail account and access this URL colab.research.google.com, and I'll take you through this. So this is a hosted Jupyter environment. Okay, I'll take you through this and what are the pros and cons with this and what we can do. Later, if you find this is not up to your speed or this insufficient, then maybe we can looking at Jupyter installation at local. I believe there are no other questions around this. If so, then we can park here and maybe we'll meet again at 11:30.
And one more request, if in case it is going to be a hands-on session for next 2 sessions, so we request the participants to connect via laptop if in case they want to do this one via this sessions and all for the hands-on. So if in case mobile, then I don't think so it will be possible with that speed, no? So we request,
mobile, then simply they can watch.
Yeah, that's it. So in case they want to experience this hands-on session, we request you to connect via laptop. Thank you. I think, sir, we'll end this session and we'll go for a break, sir, for 30 minutes.
Yes, 30 minutes. So next, Madhi, when can we meet again?
It's supposed to start by 11:30, so we'll give extra 5 minutes, sir. 11:35.
Fine, that's fine. Madhi, I'll mail you certain data files. Maybe you can, if you can put it in the share drive.
Yeah, we have a cloud link, sir. We have a cloud link. If you can able to share me, then that is fine.
How should I do that? I should mail you the content then so that you'll upload, or can I directly upload
that will be fine, sir. That will be easy.
Then I'll mail it to you in a couple of minutes.
Please, sir. No issue. Thank you, sir. I'm disconnecting this session.
Thank you, sir. Thank you, sir, for valuable information. Thank you.
Thank you, everyone, for your time.